This is the second part of the video about thermochemical equations. So we're gonna have to utilize the exact same equations, which is Q is equal to mass times specific heat times change of temperature to get the amount of heat needed to raise the temperature, or to the amount of heat absorbed to cool it down. We're gonna have to follow the steps 1 through 4 in order to do problem solving for the question on the left hand side. So question 1, it says, I'm not saying, it's question 1, okay. That question says how much or how many grams of aluminum would require 2000 joules of heat to raise its temperature from 35 degrees Celsius to 100 degrees Celsius. So to repeat the questions again, how many grams of aluminum would require 2000 joules of heat to raise its temperature from 35 to 100 degrees Celsius. So step 1, we're gonna have to identify what the question is looking. So basically the question is looking for M. We don't know M. That's what step 1 is suggesting. So now we look at step 2, identify known given information. So I'm just gonna go ahead and do this. 2000. We know that Q is equal to 2000 joules. Let me do it again. 2000 joule is the heat is Q because the units. Raise its temperature from that. So we know that change of temperature is equal to 100 degrees Celsius minus 35 degrees Celsius, and that gives us 65 degrees Celsius. Step 3, determine which equation can be used to to apply. So I'm going to show you 2 different ways for you to do it. You can use this one, Q equal to specific heat times T, or you could just use normal one. 2 different ways for you to do it. The third, so determine which equation can be used. That has been done already. We can use 2 different equations. Substitute note where we use 2000 joules here, specific heat of aluminum. So you're gonna have to go back to see where aluminum is, which is Al, which is 0.89. If they don't tell you, you need to know that from the table, or ask the teacher. If you don't need one, I'll look it up. The change of temperature is 65. So this one is a little bit tricky. So all you have to do is just do the problem solving on the top and the bottom. So it will be 2000 divided by the products of multiplication of 0.9 times 65. Which is 34.6 grams. Or you can do it this way. This way is easier. So all I did was 2001, which is the top, divide by the bottom, and press enter and divide by another bottom. So that it will give you the same thing. It's faster that way. The second one here, just go ahead and 2000 right here is equal to the mass. That's what we're looking for. Specific heat is 0.89. Change of temperature is this one. So basically you have to do the multiplication of these 2, which is 0.89 times 65, and that's give us 57.85. 57.85, 2000. So you have to divide this one by itself, both sides of the equation. M is equal to 2000 divided by 57.85, and the answer is exactly the same, which is 34.57, which is 34.6 grams, which is exactly the same thing. You can do 2 different ways. Whichever way you prefer, that's is your preference. I don't mind, as long as the answer is the same. So second question, A block of iron weighing 150 grams is cooled down from 100 degrees Celsius to 65 degrees Celsius with the release of 2362.5 joules heat. So calculate specific heat. So this one, you know this, that you are asked to calculate the specific heat of an iron. So your answer at the end of this process, it should match out with that one, which is the one on the table. Follow step 1. Identify what the question is looking for. The question is solving for specific heat. So I'm just going to say C, we don't know. Because C refers to specific heat of a certain element, which is iron in this case. We know that the mass is 150 grams, and we also know that the change of temperature is equal to 100 minus 65 equal 35 degrees Celsius. And we also know Q is equal to 2362.5 joules. So third one is to determine which equation can be used to determine. Since you're looking for C, you can do two different ways, just like I told you. So it will be C, Q divided by mass times change of time, or you can do this. Q is equal to MC delta T. So in this case, I'm just going to do this one first, since we know the known value of this one, Q, is equal to the mass, which is 150 grams. We don't know C, put C there. The change of temperature is 35 degrees Celsius. So what I would do is that I would multiply 150 times 35 to get the product of that one first, which is 5252. C 235. So we have to divide both sides by the same amount on both sides of the equations. One other misconception is that sometimes, you solving for this one, you divide that one by itself. No, that's not how you do it. You can ask your algebra teacher. You're supposed to divide whatever the term is in front of your variable. So C is equal to 2362.5 divided by 252. That should give you the exact 0.45. Let me see if you can see it from there. Same thing here. 2362.5 joules divided by the mass is 150. Change of temperature is that one. So when you do the math, so I'm just going to show you this one. 2362.5 divided by 150. Enter. Divide by 35. The answer is exactly the same. This one is much easier and in a simpler way if you know how to use it. You have to divide twice, which is 0.45 units is joules, grams, Celsius. Let me replay. Okay, units of joules, grams per Celsius. The reason why you know this is C is the units. So when you go back over here, you should be able to confirm that your specific heat of iron is exactly the same thing as the one from the table, because this information came directly from multiple and several experimental values. And it has to be this one. We are using this one as a reference. So I hope this helped with specific heat worksheets.